Solving quadratic equations part 1. In this video I'll be showing you how to solve quadratic equations using the factoring method. But before we start solving equations, let's review some things. The first thing that we are going to review is names of polynomials. And before we actually get to that, let's review what a polynomial is. My definition of a polynomial is a string or a sentence of mathematical operations. Those operations can include addition, subtraction, multiplication, or powers. They do not include more difficult operations such as square roots or fractions or absolute value or anything like that, especially when it's over the variables, but that's okay if it's over the numbers. An example of a polynomial looks something like this. 9x to the fifth minus 3x squared plus 7. Here is a string of mathematical operations. So that's what polynomials are. Now the most important vocabulary word that goes with polynomials is the degree of the polynomial. And we can pick out the degree by the highest exponent over the variable. So in my example here, it is a degree 5 polynomial because that's my highest exponent. If your polynomial is in the correct order, if it's in descending order, then it should always be the first one. However, don't expect the polynomial to be in that order because sometimes the homework or the exams, they like to trick you. So always double check to make sure that you have the highest polynomial. Now, once we pick out the degree of the polynomial, we can figure out what one of the names of the polynomial is. Remember, there's actually two different ways to name polynomials, one of them being on the number of terms it has. So my example here has 3 terms, so it's a trinomial. The other names that we could possibly use are monomial and binomial. So that is depending upon the number of terms. The other way that we name polynomials is focusing on their degree. If it is a degree 1 polynomial, then it has the name of a linear polynomial. And that's what you did on your last homework assignments, is you figured out how to solve linear or degree 1 equations. This time, we're going to focus on degree 2 or on quadratic equations. Okay. We might also see some examples of degree 3 or cubic equations or degree 4 or quartic equations. But this assignment, our main objective is solving quadratic or degree 2 equations. Now that we reviewed what a quadratic equation is, along with other things, let's review how we solved those linear equations. To solve degree 1 equations, our goal was to isolate the variable. And you did that by following these steps here. First, you simplified both sides of the equation if you possibly could. Then you rearranged things around the equal sign by moving it from one side to the other using opposite operations. Don't forget to do it in reversed order of PEMDAS. So you want to add or subtract before you multiply or divide. And at that point, you should have your variable isolated, and then you can always check your solution by substituting those values back in. Alright, now let's look at an actual example that we'll be doing here in just a moment. This example is x squared plus 3x is equal to 18. What I want you to notice is that you cannot solve this one by using your linear methods. You cannot solve it by isolating the variable. And the reason that you cannot do that here is because we actually have more than one variable. We have a x squared here, and we have a 3x or an x there. So I cannot isolate the x because I see 2 of them. And I cannot combine these 2 x's because they are not like terms. So you cannot solve quadratic equations or anything higher like cubic or quartic equations by using your linear method. That's why we have to come up with new steps. before we actually get to the steps, we need to learn one new principle. So let's review our linear principles that says if you do something to one side of the equation, it is okay as long as you do it to the other side of the equation. So you want to keep your equation balanced. So if you add, subtract, multiply, or divide something from one side, you have to do it to the other side as well. So that's how you rearrange things around the equal sign. Now when we're solving quadratic equations, we need to use this new principle called the principle of zero products. It says if you have something times something else, and if that is equal to 0, then the only way that this equation will work out to be true is if your first piece is equal to 0 or if your second piece is equal to 0. So if I were to plug either of these back in, so if A is 0 and 0 times B, that is of course going to be 0 in itself. If B is 0 and I take A times 0, that of course will be 0 as well. So reviewing this property one more time, if you have something multiplied by something else and it is set equal to 0, then your next step is to set each factor equal to 0. Now that we know this principle, we can actually learn the steps to solving quadratic equations using the factoring method. Now there's going to be more methods coming up in other videos. This one here is focusing on the factoring method. This method works not only for quadratic equations, but it works for any equation higher than degree 1. So degree 2 quadratics, degree 3 cubics, degree 4 quartics, so on and so forth. As long as your polynomial factors, this method will work. The steps that you're going to follow is first, you want to set one side of your equation equivalent to 0. If this is a quadratic equation, it's what we call by putting it into standard form. Standard form is when it's equal to 0 and it's put in the descending order. What that looks like is ax squared plus bx plus c is equal to 0. So this is a quadratic equation set equal to 0 in descending form. So it is in standard form. Alright, once we have it equal to 0, the next thing that you do is you factor, and make sure you factor it completely, doing all the factoring steps. If you have forgot the factoring checklist, don't be afraid to go back and reference that video from a different week's content. Then we use our principle of zero products and we set each factor equal to 0. Remember that principle says if we have something times something equal to 0, then either your first factor is equal to 0 or your second factor is equal to 0. After you do that, you should have it down to linear equations, so you can just solve those by isolating the variable. And then, last but not least, don't forget to check. Now, one thing that you need to check is that you have the correct number of solutions. And the way that you should do that is the degree that you have should match the number of solutions. So if it's a degree 2 or a quadratic equation, it should have 2 solutions. If it's a degree 5, it should have 5 solutions. So first check that you have the right number of solutions, and then second, check each of those solutions individually to make sure that they work. Now that we know the steps, let's go and do this example that we talked about previously. We have x squared plus 3x is equal to 18. If you've forgotten the steps, I have given you kind of a cheat sheet up here to follow. And if you would like to work this one on your own first before you watch me do it, the answer is listed right here for this problem and all problems following. Alright, the first thing that we need to do is set the equation equal to 0. This is a quadratic equation, so that's what we call by putting it into standard form. What we want to do is we want to move 18 to the left. And I want to do it that way for a couple of reasons. Number one, it's going to be easiest just to move one term rather than move 2 terms. But actually, more importantly, the reason that I want to move 18 to the left is because I have x squared on the left and it's positive. I want to make sure that highest degree or that leading term is positive. That's going to make your next step of factoring a lot easier. Alright, so since I subtracted 18 from both sides, putting it in descending order gives me x squared plus 3x minus 18 is equal to 0. So I have accomplished step number 1 by putting it in standard form. Step number 2 is factor completely. In this one, following my factoring checklist, I do not have any common factors. I count the number of terms. There's 1, 2, 3 terms. So I factored this one as a trinomial, where I set up my parentheses to reverse FOIL it. Now don't lose that equals 0 here. That's the difference between solving equations that we have here and just factoring that we did previously. Alright, starting with my first term of x squared. Putting it in the first places, x times x gives me x squared. Moving to my last term of 18. I want to think of what times what gives me 18. I have lots of choices, 1 times 18, 2 times 9, and 3 times 6. I'm going to use my options of 3 and 6, and I'll explain why here in a second. Alright, now I want to double check that my outside and my inside work properly to get my middle term of 3x here. Well, if I multiply my outside together, that gives me a 6x. If I multiply my inside together, that gives me a 3x. And I want to add or subtract that to give me my middle term of 3x. Well, this works, which is why I chose the factors that I did. If I have a positive 6x minus 3x, that gives me a positive 3x. So I find my 6x, make it positive. I find my 3x, make it negative. And double check that last sign. When I multiply negative 3 times positive 6, that does give me a negative 18. So I have factored it. Not only have I factored it, but I have factored it completely, because each of these parentheses only have 2 terms, where there's no squares nor cubes. So I have accomplished step number 2. Step number 3 is use that principle of zero products, where I have my first set of parentheses times my second set of parentheses and set equal to 0. So it's in the format that applies me to use that principle. It says I can set my first factor equal to 0, or I can set my second factor equal to 0. So I have done that. Now I just solve what I have left, solve them one at a time. These are both linear equations, so I solve them by isolating my variable. On the left, I add 3 to both sides, gives me the answer of x is equal to 3. On the right, I subtract 6 from both sides, canceling out those 6's, gives me the answer of x is equal to negative 6. Now, depending on how the homework asks, it wants you to input the answers in one of 2 ways. The first way is it's going to ask for the solution set. It wants the set of numbers that makes this equation true. If it asks for the set, then the answers need to be in the braces. Then you input your answers with commas in between. So 3, negative 6, or you could do it as negative 6, 3. Order does not matter. The other way it might ask you for your answers is it might ask you what your variable, in this problem specifically, what does x equal? If it asks for that, you do not need to input your answers in parentheses. You just need to list them down with commas in between, 3 or negative 6. So, again, one of these 2 ways is going to be the answers. If it asks for the solution set, you need to put it in parentheses. If it does not, you just need to put in your answers there. So I have solved those remaining equations. Now I'm going to check. Remember, my first check is, do I have the right number of answers? This is a degree 2 problem. I should have 2 answers, and I do. One of them being 3, and one of them being negative 6. Since I have the right number of answers, let me now check, do my answers themselves work out the way that they should? So let me first check x equal to 3. This means I'm going to plug 3 back into my original equation and for all of those x's. So first I have 3 squared plus 3 times, again, plugging in my x value of 3. And we want to know, does that actually equal the 18 that we're hoping for? On the left, 3 squared gives me 9, plus 3 times 3 gives me 9, and 9 plus 9 gives me 18. So that one works out, so x equals 3 is for sure an answer. Now let's check the other one. Here we're going to check if x is equal to negative 6, if that works out properly. Plugging it back in, first I have negative 6 to the second power plus 3 times, again, inputting my x value of negative 6. And one more time, we're asking ourselves, does that equal 18? Well, on the left, negative 6 squared, which is negative 6 times negative 6 gives me a positive 36, plus 3 times negative 6 is a negative 18, and of course 36 minus 18 does give me 18. So that also works as an answer here. So I have checked my solutions. Now that's where I'm going to stop this video, but in the next video I have quite a few more examples of solving using the factoring method.